Dear students and the participants of the course on railway engineering, we will be continuing discussing about the joints in the rails, and today our main focus will be shifting to the flush butt joints or the welds. If you remember, in the previous lecture we started discussing about the various special joints and we discussed the insulated joints, and then we talked about the welded joints, their advantages, and shifted to the one of the weld type of a technique which is being used on Indian Railways, that is aluminothermate welding technique or AT weld, and we discussed about the different advantages or the type of rails which should be used when we are going for this AT weld. Towards the end of the previous lecture, uh, we were due to discuss about the various executions and precautions measures which should be taken for AT weld, but could not be taken, and that is what we are now going to discuss in this lecture. And then we will start discussing about the FB weld, that is the flush butt weld. So, let us first of all talk about the execution and precautions related with the AT welds. Now, AT welds, they are done in situ and they are joggled fish plated. If you remember, I told you there are standard fish plates, there are combination fish plates and there are joggled fish plates, though we will be discussing about this type of fish plates when we will take up the fastenings, but this joggled fish plate, some idea was given in the previous lecture where it said that if you are using the already used fish plates which are having still the service life, then they are being thickened at the central portions, and those type of fish plates when they are used, they are joggled fish plates. These are used with two clamps and they are supported on a wooden block of length 300 to 450 mm. So, that support is being provided at that particular location. It may be because of the defects which may be there in the rails, or there may be excessive wear at that point. But if it is said that you go for a USFD testing, that is ultrasonic flaw detection testing, and it test is in terms of a result as good, then these things can be removed. Then these joggled fish plates with far end bolts shall be provided at the AT welds, which have undertaken traffic equal to or more than 50% of the stipulated fatigue life in gross million tons of the rail. Okay, so this is another measure which has to be taken as a field engineer by you if you are working in the Indian Railways. And the joggled fish plates with clamps on two far ends, bolts on the good AT welds shall be provided on banks having height 5 meter or more. So, this is one another case when you have an embankment. So, you are going a bit high as with respect to the ground level, and there we are discussing about the use of the joggled fish plates with the clamps or the two far end bolts. Then these joggled fish plates with clamps or two far end bolts on good AT welds shall be provided on the bridges, and they should have a length of a waterway as 100 meters or more, if that is the span of the bridge, and its approaches up to 100 meter length. So, on both the sides, so if you have a bridge being provided here, so that is what we are talking. So, the length of the waterway here is being considered as 100 meters and approaches up to 100 meters on this side and up to 100 meters on the other side. Then joggled fish plates with clamps or two far end bolts on good AT weld shall be provided on curves of 3 degrees or sharper. So, the same thing we discussed previously was when we were talking about the track which is on an embankment where the height is 5 meter or more. The another case is that if you have a curve which is 3 degrees or sharper, then in that case also this joggled fish plates with two clamps or the two far end bolts needs to be provided for good AT weld. Now, here certain tolerances have been shown, and those tolerances are like vertical alignment and the lateral alignment tolerances. In the case of vertical alignment tolerance, what it says, the variation shall not be more than plus 1 mm and minus 0.0 mm. So, that is the range. but the negative side it is not going down, but up to the positive side it can be 1 case measured at the end of the again 1 meter straight edge. In the case of the lateral alignment, then the variation shall not be more than plus minus 0.5 Now, you have a negative side also, not 0, but minus 0.5 measured again at the center of 1 meter straight edge. So, that is the way we are discussing it. Now, here in the diagrams also it is being shown, say this is the straight edge being placed on the side as been shown here, and this is placed at a distance of 14 from the tabletop, that is the top of the rail. And once it is being placed, now it is trying to examine that if there is any shift here. So, that particular shift is being measured. So, this shift is being found here. So, this is say up to 1 Whereas, in the case of the lateral conditions, so if we are talking here the lateral conditions, the gap is coming here at the center of the 1 meter straight edge, and this is to be looked at as plus minus 0.5 Now, then in the case of this first one, the tolerance for the vertical alignment at the time of welding is being talked, wherein at the top we are putting the straight edge. So, it is being placed at the top here at the center of the rail head, and then we are trying to measure that what type of deviation is there, and it says it is 3 to 4 in case of the rails and 2 to 2.4 for higher UTS rails. That is the limit being defined. Whereas, if we are talking about the lateral condition, then what type of change in the alignment which is there is again being examined using a 1 meter straight edge, and at the center of it the value is 0.5 So, that is the permissible limit which is being given. And if we talk about the vertical misalignment, that means the two rails which are being placed, now they are having a top portion of the rail surface which is a bit up and down, then in that case the range is plus 1 to minus 0.0 So, that is how it is being specified, and this is as per the permissible limits which are being given by the Indian Railways. Then another is the finishing at the top surface. So, this is the top surface of the rail head. At this we are trying to look at the finish. So, finishing on the sides of the head of the welded joint. So, when you talk about the side, so that means this is the side which we are talking here. And another one is this is a finishing top table surface of the welded joint. So, it means we are talking at the joint, and there at the top we are putting it as a straight edge. So, what it says plus 0.4 to minus 0.0 which is measured at the end of 10 centimeter straight edge, not 1 meter straight edge. And then another is the head finishing on the sides plus minus 0.3 over the gauge side, the side towards the which the other rail is also facing, and it is measured at the center of the 10 centimeter straight edge. So, here now you are having a smaller such straight edge, and then we just put it at the location and we try to identify what are the variation which is coming in. Now, let us talk about the flash butt welding of the rails. Now, in the flash butt welding on the rails, it is using the principle of softening of interfaces by electric current, and then it is being butt, the rail ends are being butt under the pressure of the welding. That means, you just bring in the two rail ends after the process being done together. So, this is what is the butt condition, they are being jointed together like this. And this flash butt welding that can be done by stationary flash butt welding plant or a mobile flash butt welding plant. There are two ways in which it can be done. Now, what type of rails can be selected when if you are going for a flash butt welding, and that is the similar way as we talked about the AT weld also. So, the rails of the same section shall be welded together. There also we said that the rails should be of same section, but if it is of different sections, then we need to take care of the top surfaces which are matching in terms of a vertical or the horizontal alignment. The minimum length of old but serviceable rail for welding shall be 6 meters. So, you have got already the rails are available to you which has been used previously, but you found they have not reached a life of 50 years. They are less than that, and we say that they still have the serviceable life available in them on the basis of various tests also. Then the minimum length which has to be considered is 6 meters. If it is less than 6 meters, it should not be used for the welding. Before releasing from the track, the older rails shall be match marked. The same thing as we discussed in the 80 weld. You have to look at that if this is a rail and this another rail. So, if it is left side rail, inner side, outer side. So, this one and this is a left right, inner side and outer side, and then it is which side of in terms of the movement at what particular location this is being provided. So, that mesh marking is to be done, so that once you come back after removing it, when you bring them back, put them back for welding, then that is identifiable. The welded panel shall be without the fish bolt holes, the same condition as we discussed in the case of 80 weld. Now, if fish plate bolt holes are unavoidable, then outer edge of the hole nearest to the rail end shall be 40 mm away to avoid heat affected zone extending up to the edge of the hole. So, if we have a rail and this bolt hole cannot be avoided, you cannot crop it. So, in the case of 80 weld, we said that you should crop it and then use it for the weld. Here what we are saying, if it cannot be removed, then this bolt hole which is nearer to the end, this shall be 40 mm away. So, that means it should be more than, this distance should be more than 40 mm. Otherwise, when you are using it for the welding with the other rail, then whatever heat is going to be generated here, that will reach to this particular location and it will create problem here. All fish plate or all fish bolt holes, they shall be chamfered before welding, the same point which we discussed previously, and of the old rails with fish bolt holes or the bond wire holes, they shall be cropped by a minimum length of 450 mm before welding. So, if this is a case, any of such thing is there, first of all we will try to crop it down to a level of 450 mm, but if it is not possible, then we have to take care of that at what is the distance of a hole from the rail end. The rails having cracks or other defects such as heavy corrosion pits or which are worn by more than 2 mm depth at the rail seat shall not be welded. So, there also we talked about if there is excessive wear or there is a corrosion, then that rail should not be used for the welding. Here also we are talking about the same thing, and here it also talks about the wear at the rail seat, that means at the bottom here which we are looking at. So, this is a rail seat location. So, if at this particular point the wear is more than 2 mm depth, then it should not be used. Now, selection of the rails for welding. The vertical wear in the old rails to be welded shall be within the limits for the 2 rail sections which are widely being used. I have taken that only here. So, standard height of the new rail is 172 or 156. We discussed about this previously too, and this is 164 and 150. That is the limit which is given in the case of flesh butt welding also. So, it is the same almost as which we have discussed for the 80 weld. The rails with cyclic wear shall not be welded. So, it is a case that you had a wear, then you improved upon it by way of different measures, and again the wear appears at the same location. So, that is a cyclic wear which may be happening. Then the lateral wear in the old rails which are to be welded shall have similar pattern of side wear, and the minimum width of the rail head shall be within the limits as being defined here. The standard width of the rail head 72 and 67, with respect to that it can be 66 or 61 respectively for the 69 kg per meter or 52 kg per meter rail section. So, this is another limit being defined for the lateral wear. The individual rail ends for new rails may have a maximum difference in the height of 1.2 mm at the welded joint. So, if we are having two rails and those two rails have been connected together, so whatever is that height difference which is coming, so that height difference is being talked here. The rails which are manufactured by SAIL and which are having a letter D being engraved on it as a rolling mark, then the maximum difference in height can be up to 1.5 mm instead of 1.2 mm. So, it means it also differs with respect to the manufacturer and the type of rail which has been manufactured. The difference in the width of the rail heads of the two rails to be welded shall not exceed 1 mm for new and 2 mm for old rails. So, the whatever is this width which is there, this is what we are talking here. So, there is the height of the rail sections and there is the width of the rail sections, all of these things has to be taken care of. And all these joints which are there, these are the locations where the weldings are being done. Now, for rails which are manufactured by SAIL and with letter D in the rolling mark and with maximum difference of maybe 1.5 mm, new rails it is preferable to restrict the difference in width of the rail heads to 0.5 mm. This is another point which of course, we discussed the previous one also in the previous slide itself, just a repetition which has come here. And when it is not possible to identify the gauge face of the rail in the depot because you have not done the match marking. So, it becomes difficult now to identify that, then the difference in the width of the rail heads shall be transposed to one side of the head and the other side perfectly aligned. So, if there is a difference in this width of the rail head, so whatever is the width which is there, this is what we are talking. So, if another one which comes is having another difference, another value. So, what you need to do is at one particular side it has to be matched perfectly and then whatever the variation will be there, which will be on the other side. Now, rail ends geometry which is to be followed. So, here the rail and bands in the vertical plane shall not be greater than 0.7 mm on a 1.5 meter straight edge. Previously, we talked about 1 meter and 10 centimeter sort of straight edges, but here what we are talking is 1.5 meter. So, in this 1.5 meter, if you see there is a rail end which is being welded here at this point. So, in this case once you put this 1.5 meter at the center, the values they shall be within plus 0.7 and minus 0.0 mm, that is the limit being defined. In the case of horizontal plane, it shall not be greater than plus 0.7 mm on a 1.5 meter straight edge. So, it is a vertical plane as well as horizontal plane, the value is same and the same straight edge is being used here. The deviation of the end from the square not greater than 0.6 mm. So, now that means you are talking about the end here. So, when you are talking about this end, so here also this is the rail end which is being welded. So, at this particular point the check has to be done. The rails shall not have a visible surface defects, the wheel burns, the chisel marks, the dent on the bottom flanges, etc. So, whatever the different type of the defects or the wears which can be there, they shall not be present here. So, you can see some of the things in this case. Now, this is a rail and here some deviation has come. So, we are using a 1.5 meter straight edge. So, deviation cannot be more than plus 0.7 mm and the minimum value has been minus 0.0. So, here it is being placed at the rail end in terms of a rail end square condition is being checked. Here you can see there is a deviation which is coming, and this deviation shall not be more than 0.6 mm positive. So, that is a range which is being defined. So, it can be either the head or the rail, and these have been placed, and when you put it in a plan or in a vertical frame, then that is how it is going to show you. Similarly, when you talk about the wears and the head, then that is what it shows, that you have a normal section and there can be a weird section being provided, and there is some tolerance which is already being given for these particular type of cases. Now, what are the steps which are followed in the flash butt welding of the rails? So, steps are, first of all, we need to align them. We did talk about that those things needs to be checked in terms of the vertical or the horizontal plane or the lateral direction, the kinks, etc., which can be there, which needs to be checked. They should be in the permissible limits. Then if there is an initial burn off or the preheating which is to be done, this again we discussed about that this preheating is done, and therefore, what should be the distance of a hole, or it should be cut off in certain length. Then flashing will be the next thing, then forging and stripping. These are the various steps which are used in the flash butt welding of the rails, but again we are not going into the details of all of these uh, various types of procedures or techniques which are there. Now, certain recommended values in terms of, say, the butting pressure for the rails, for the 72 UTS rail, for 90 UTS rail, and for 110 UTS rails, these values have been given. So, these are like 5 kg per mm square on a cross sectional area in the case of 72, in the case of 90 UTS, or in the case of HS rails, and this is head hardening rails, defined as HS rails also for your information. So, this is 6 kg per mm square on the cross sectional area. In the case of 110 UTS, then it becomes 7. So, it is 5, 6 and 7 as the ultimate tensile strength of the rail increases from 72 to 90 to 110. Now, heaviest rail section which can be welded should be decided on the basis of those above things. Now, welding of the higher UTS and the higher section rails shall not be done on low butting load. So, if we are talking about higher UTS rails, the no butting load should not be used, and we should not say that we have used a low butting load and at the same time we are increasing the number of preheats. Now, this is a bit detrimental to that weld. So, this will cause what? This will cause very pronounced heat affected zone, and this is going to create a problem in terms of the service life, because that particular zone will be more prone to certain type of distresses or defects which can appear over the time period. Now, post well head treatment is required for 110 UTS and as well as HH rails, whereas in the case of 72 UTS or 90 UTS rail sections, this post weld treatment is not required. Now, coming to the marking of the joints, how these joints are marked. So, if we just talk about the two types of the plants which are used, one is a stationary plant, another was the mobile plant. So, here we are talking about a stationary plant if it is being used. So, in this case the coding goes in this form X, 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 X. So, there are 4 letters here, then you have 2 as mm, then 2 again as YY, and then 3 as AAA. Now, what these stands for? So, the first one, which is a 4 letter system, this is basically a number which starts as 0001 for the very first weld of every month. So, what we are doing is every month we are going to do the welding. So, whatever is the month is there. So, if it is May, so that means we are talking about 05. It is being done in the year 24. So, this is 0524. Now, in this 05 month, how many welds are being done? So, starting from 0001, it will keep increasing. And then AAA, this is the code of the welding plant. Say for example, one code is being given here. This is MGS. This MGS is for the Mughal Sarai flash butt welding plant. So, that is way the different stationary plants will be there. They all stationary plants will be having a code, and that code is used here as the 3 letter system. In the case of a mobile plant, what is the difference? So, first 4 then 2 and 2 they are same, the only difference is coming after that in terms of 2 things coming as O, 2 coming as PP and then EE. So, it has become a bigger coding. So, XXXX, so that remains the same, being talking about the welding number which is being done in a month. Then you have a month of the welding, then you have the year of the welding. Now there is a change, previously it was AAA which was a stationary welding plant code. Here OO is the code of owner of the plant who is coming with this mobile plant. PP, this is the code of the plant owner, and EE is the code of agency which is executing the welding. So, from where it has come, who is having that with him or her, and then who is executing. So, whole information is being embedded there, so that tomorrow if there is an issue which faced at that location, then the people can be contacted accordingly. Now, what are the various tests which are conducted on the joints? There are visual inspection, that was the same as we did talk about previously. Dimensional check was also the same one. Ultrasonic test was also the same one. So, these 3 are the same one. The 3 which are increasing here, they are a hardness test, transverse test and macro examination. So, these 3 is additional values which has to be found out and reported. Now, coming to the braking load and deflections here. So, the rail sections are being shown in the first column. As you see, there are 60 kg and 52 kg rail sections with different strength parameters in terms of a UTS, that is ultimate tensile strength, 72 or 90 UTS sections, they are being talked, along with the steel grades being defined, and the steel grade here is defined as 1080 and HH is the head hardened rail. So, its grade is 1080 HH rail, where CR is the chromium rail being used here. So, in these particular cases, that braking load and deflections which we are talking, there is a span which is considered is 1.25 and 1.25 meters in the case of 60 kg, but high steel grade sections. But if it is a normal sections like 90 UTS or 70 UTS, then their length is being taken as 1 meter. The minimum braking load are being defined here. They are ranging from, as you can see, from 100 tons to 150 tons. So, these are the different values which are there. Similarly, in the case of minimum deflection at the center in mm, it is quite low in the case of 60 kg UIC grade 1080 CR rail section, but otherwise mostly it is either 20 or 30 mm as a deflection. Then the finishing tolerances for the welds can be there. Now, this can be there for the new rails as well as for the old rails. Here they are being talked in terms of lateral misalignment, the vertical misalignment, the head finishing in width, the finishing on top table surface as well as in the web zone. So, if you remember, we have seen the diagrams how it is being done using a 1 meter straight edge or 1.5 meter straight edge or 10 centimeter straight edges. So, those we have already looked at it. So, here the values have been reported again for those finishing tolerances. In the case of vertical alignment, it is positive 0.3 to minus 0.0 mm at the center of 1 meter straight edge. In the case of lateral misalignment, it is plus minus 0.3 mm. So, instead of minus 0, it is minus 0.3. Again, the straight edge is 1 meter, at the center of that it is being identified. Whereas, if you are using it on the side of the rail head, because head finishing in width is being considered, then this is plus minus 0.25 mm on the gauge side at the center of 10 centimeter now, which is being used. Then, in the case of top of the rail section, then it is plus 0.2 mm to minus 0.0 mm. So, that means there is no such value here, and then again here the straight edge which is being used is of smaller size, that is 10 centimeters. And in the case of web zone, so this is the web portion which we are talking here now. So, in this case it is plus 3 mm to minus 0.0 mm on the parent contour. So, whatever contours of the web zones are there, that is taken accordingly. So, here this things are being shown again. So, what you can see is this is the welded joint which is being provided. At this point 1 meter straight edge is being placed. If there is a gap which is coming, then that gap has to be between a permissible limit. Similarly, in this one there is a 10 centimeter straight edge is being used, and 10 centimeter straight edge when it is being used here, then this is what is the permissible limit. Similarly, when you talk about the other side here, then in this case it is being placed on the side of the rail head, and when it is placed on the side of the rail head 1 meter such edge is being used and the value is 0.3 mm. And here at the again in this particular case when we are considering a 10 centimeter one, it is 0.25. So, all of these things they have been taken from the flesh butt welding manual of Indian Railways. Now, there are finishing tolerances for the welds of old rails. So, in this case again the same things have been considered: the vertical misalignment, lateral misalignment, head finishing on sides, and the finishing on top table surface, web zones. So, in this case the values are again being given like plus minus 0.5 mm, but the straight edge is 1 meter, again plus minus 0.5 mm at a straight edge of 1 meter for vertical and lateral misalignments. In the case of head finishing on sides, plus minus 0.3 mm using a 10 centimeter straight edge. So, it is the same as we discussed previously, plus 0.2 mm on the gauge side of the 10 centimeter straight edge when you are talking about the top of the head of the rail, and plus 3 mm to minus 0 mm in the case of parent contours when we are talking about the web zone. So, this is regarding the old rails. So, here again they have been shown. What you can see is that this is a straight edge 1 meter, and this 0.5 mm is the permissible limit which is being given here. In the case of sides, again it is 0.5 mm and 1 meter edge is being used. Here in the right hand side, the diagram which is there, which is showing again the straight edge being used at the top with 1 mm of the permissible value being defined here in this case. And now, if we are talking about this old rails here, then on the left hand side this is 10 centimeter straight edge, but 0.3 is the value which is considered. If you are talking about the top, then it is 0.4, but then this is again 10 centimeter one, and then 10 centimeter one at 0.2 on the side. So, that is how, means whatever type of lateral, vertical or the web conditions, all those things we have discussed at the top of the rail head, at the side of the rail head, they have been shown in these diagrams. Now, we can talk about the precautions which can be taken on the flesh butt welded rail joints. So, here the oxide inclusion is one thing. In this case it is can be taken as the rail end faces and the adjoining surfaces of the rail profile to a width of about 25 mm all round shall be first of all cleaned properly by a portable grinder or brushing machines or the shot blasting to remove the loose scales or rust or scabs or dust or paint before going into the welding, and the oil and grease if present shall be removed by carbon tetrachloride or benzene. So, first of all the cleanings has to be done on those joints. In the case of lack of fusion, the preheating cycle and time, fleshing and butting strokes, they needs to be strictly maintained. Otherwise, the fusion will not be there of the two rails. Then the rail hands having a cracks and other visible rolling defects should be cropped before welding. So, this we have already talked about. What and the another precaution is notches and chisel marks, if they are there adjacent to the point where the welding is to be done, then they again shall not be there, they have to be removed. Then loose oxide and the metal shall be cleaned by, as we just talked about previously, the brushing the copper block surfaces, and the copper blocks shall be periodically reconditioned and replaced with the new ones. The treated water should be used for cooling systems so that the scaling of the inner side of the pipe does not take place. So, this is another thing which has to be taken care of, and squareness which we have used by using a square like this, and that of the rail ends must be ensured. Then secondary output of current should be sufficient enough to achieve complete fusion of butting faces of the rails. This is Another thing, then butting stroke should be sufficient for complete the coalescence and it should not be less than 12 mm here, and the throughout uniform and smooth auto trimming of the squeezed out metal and complete grinding using the profile grinder around the butt joint is essential. There is a possibility that if we have jointed it like this, there is some metal which has come out, so that has to be grind. And finally, what are the other two things are the minimum and the nearly parallel heat affected zones of the joint should be achieved. And when welding is carried out in situ, then minimum 20 minutes time after the trimming is required to pass strain through the weld with proper packing and support below the joint. We did talk about a wooden support which has to be provided, and after the USFD, if it says that the weld is good, then only those particular things can be removed. So, at this time when the train is being moved, so there can be a restricted speed also. So, with this we close over this lecture. What we have discussed is initially the precautions which are there for the 80 weld, and then we started discussing about the flash welding, and we talked about the type of the rails which can be used, various steps which needs to be taken, what are the recommendations, how the markings are done on the weld, what are the various tolerances, and the precautions should be taken when we are going for FB weld. Thank you, and we will be meeting in the next lecture.